Okay. So, well, let's think about this. All right. So the clearance is constantly changing with, or the clearance is changing with concentration. So we're going to think about the fact at steady state, we know the rate of drug loss is going to be equal to the rate of drug administration. So the milligrams per day being removed, or the rate of drug loss, is going to be equal to the rate of administration. So if we use R as the rate of administration in milligrams per day, or daily dose, or dose rate, our dose rate is going to be equal to Vmax over Km plus C um, times C. So we would use this to calculate our daily dose rate. But we still have two unknowns. So this we're trying to figure out, right? We know our target concentration. We still don't know Km or Vmax, so it's going to be hard to figure out our dose rate because we've got three unknowns actually here. So what we can do is put in our target here and use a Km, or I'm sorry, here's our population guesses or ranges for Km and Vmax. So adults have a Km of 7 milligrams per kilogram per day and a Km of 4. Kids have a higher Km, as you can see, at 6 milligrams per liter. And then their Vmaxes are also larger than adults. So we can use these population numbers. Now, if once we've got one dose, if we start them after the initial dose and we put in the dose rate that we gave and the concentrations that we got, then we can put in a population average KM of 4 and solve for our patient's Vmax. Is it going to be perfect? But no, but it'll be better than nothing. So you can do that, and then you figure out the patient's Vmax. Then you put in their Vmax, their Km, and whatever target concentration we're shooting for, and solve for a new dose rate. So here, AM is a 40-year-old, 5'9", 78-kilogram man suffering from epilepsy. He needs to be started on oral phenytoin. Please determine a starting dose for sodium phenytoin. All right, so again, if we go to our patient, he's 5'9", 78 kilograms. And he wants to be, we need to start him on phenytoin. So what are we going to do? Let's see. We'll go back here. And let's say we're going to target, what do you want to target? Somewhere between 10 and 20. So let's target 12 milligrams per liter for his target concentration. Our Vmax is going to be 7 milligrams per kilogram per day. And he weighs, I just wrote this down, 78 kilograms. So 78 times 7, our Vmax guess is going to be 546 milligrams per day times 12 milligrams per liter over a Km of 4 milligrams per liter plus 12 milligrams per liter. So let's see, we'll plug and chug that. I got 409.5 milligrams per day. So 409. So I'm going to recommend 400 milligrams to start with. We can give that once a day or twice a day. If you're going to give it once a day, you should give it at night because they could be a little dizzy and they would sleep through that probably. Or you can give them 200 BID. So I would recommend 400 milligrams a day and expect that we would be close to our goal of 12 milligrams per liter. So what about a loading dose? Do we figure out a loading dose? I guess we didn't. Um, let's go back here. So he's He's 78 kilograms. I probably should have done this for the other. And we're going to multiply that times our volume, which is 0.7. Sorry, I'm trying to write with a mouse here. So our volume is going to be 78 times 0.7. So I got 54.6 liters for his volume. So our loading dose is going to be, we're going to give an oral loading dose. It's going to be 54.6, and we're shooting, and this is liters, and we're shooting for our target of 12 milligrams per liter. And if we're given oral, the salt form is 0.92. And I'm going to say the bioavailability is 1. We'll see how much that, just because 54.6 times 12 divided by 0.92. So I got a loading dose of 712.17. If we change this to 0.95, depends on the product, right? So 0.95 times, oops, 0.95, 0.95. What is going on here? Times 0.92. All right. Times 54.6 times 12. I got 749.6, so closer to 750. Actually, 49.7. So I'd give between 7 and 750, and it comes in 30s. I'd probably give 300, 400. I'd probably give 300 and 400 in 2 doses. That's what I would do. I don't think we're going to want to give him more than that. All right, and then our maintenance dose is going to be 400 a day. When will we check concentration? Well, we want to be at steady state. Remember, steady state's changing, the half-life's changing all the time, so the time to steady state will also be changing, but I would probably check, and so an average usually for most people is about 8 hours, so 8 times 5 is 40. I'd probably check in 2 days. And what dose-related side effects are we going to be looking for? Well, we're going to be looking for nystagmus, for any dizziness, ataxia, any mental confusion. You probably won't see any gum changes right away if there are any, or facial changes. Those would be the big things I'd look for. All right, thanks.